Welcome, grade 11s. In this lesson, we're going to continue our talk about percentage composition and empirical formulas with now the next step, molecular formulas. Right, so to determine the molecular formula of, of a substance and any problem you might encounter, we need to have two things. We need to have the empirical formula, so number one, or we'll have to calculate it from information given, such as your percentage composition, like we did in the previous lesson, and we need to have its molar mass. Right, this has to be given to you in the question. Okay, so let's start. Here's our first example. An unknown compound has an empirical formula of that. Right, so notice this is a proper empirical formula. It's in lowest terms. For every 4 carbons, you have 4 hydrogens and 1 oxygen. And the real molecular formula has a mass, a molar mass of 136 grams per mole. What is a molecular formula of a compound? So this is its most basic formula. It's empirical formula. Do we need to multiply this then by 2? Do we need to multiply it by 3, multiply it by 4? What is it that we have to multiply this by to get our empirical formula? So first, let's figure out, step 1, determine the mass, molar mass of our empirical formula. So we have 4 carbon atoms, that contributes 48, hydrogen contributes 4.04, oxygen, so on. We add all of that, and this is the molar mass of our empirical formula, right? Next step. Okay, here we're going to determine that multiple. So the multiple that we looked at here, is it going to be 2, 3, what is it going to be? All we need to do is take your molar mass of your molecular formula, right, given to you in the question, divide that by the molar mass of the empirical formula, right, determined from the empirical formula using your periodic table, divide the two. Turns out that it's double. So your empirical formula is this much, the molar mass of your empirical formula is that much, and your molar mass of your molecular is that much. Turns out they are double, which means all you need to do is multiply your empirical formula by the same value, by 2. So you get this. 2 times 4 is 8, 2 times 4 is 8, 2 times that imaginary 1 there is 2, and that is your molecular formula. Right. You can double check your molar mass of your molecular formula, and it should match. This is an assignment we would do in class. We're going to move on now to our next example. Okay, so this is a more of a typical question. Here you're not given the empirical formula. Here you have to determine it. So a good portion of this is just review. So we have different percent compositions here. 49.48 carbon. This is hydrogen, nitrogen, oxygen, right? Remember, an important step is whenever you're determining an empirical formula is always assume 100, not 100%, 100 grams. Scratch that. Okay, always assume 100 grams. That means that you can take all of those percentage values and just convert them straight into their equivalent grams. So 49.48 percentage becomes 49.48 grams, right? That makes math a lot easier. Okay, so we've done all that in our first step. Then your next step is, pausing here, so hopefully to get you to think, the next step is find the number of moles of each of the elements. Right, so all you do is divide by their molar masses. So if we have this many grams of carbon, divide that by its molar mass, do the same thing for the other elements. That's the contribution in mass of hydrogen, divide that by the molar mass of hydrogen, we get these values. Right, do the same thing for nitrogen and oxygen. Now our next step. What is our next step? Pausing here to get you to think. Our next step is we're going to divide all of these values, by the lowest or smallest value we have. So in that case, it's going to be oxygen's 1.03. And this is what we get. Turns out if we divide each of these by 1.03, we get these values, 4, 5, 2, and 1, reasonably round where necessary. And now we know our whole number values for our subscripts for our empirical formula. And that is C4H5N2O. Right, so this is our empirical formula. So review from last lesson. Okay, now we're going to take this a step further and figure out the actual formula. Now in the question, it gave us, let's go back to the question. In the question, it gave us the molar mass of the molecular equation, right? We need to figure out now the molar mass of our empirical formula, which we just determined, right? So from our empirical formula, this ends up being the molar mass. You can do all this addition yourself. Of course, these values came from the periodic table, right? That's molar mass of our empirical formula. Now, do the same thing we did in the last problem. What is the molar mass of the molecular formula? This is given to us, right? This is given to us in the question. This we determined, we calculated the molar mass of our empirical formula. You divide the two, turns out that it's also 2. Now, it's not always going to be 2, but it's also 2. So our molecular formula is really just double the mass of our empirical formula, which means all we have to do then is multiply the empirical formula by 2 as well to get the molecular formula. So 2 times all of these subscripts gives us C6H10N4O2, right? And that is our molecular formula. We can double check the molar mass and it should be the same as the one given in the problem. So in the past couple of lessons, we've done this. This is all the topics that we've reviewed. Know how they all relate and practice that in your home fun. Ask questions online, I'll answer it there.